today's major content is looking at the fundamental theorem of calculus and looking at it in two ways in which it's kind of useful to us. Number one is the net change theorem, which we learned yesterday, which is the integral from a to b of big F prime of t dt is equal to f of b minus f of a. Now, if you remember, yesterday we talked about it being a rate function. And so if we're given velocity and we take the antiderivative, we get position. And I'll show the accumulation of position, or rather the total distance traveled. And that was pretty helpful yesterday. We looked at the difference between displacement and distance. Do you remember the difference between displacement and distance? Distance was the absolute value of the rate function or the velocity function. Very good. Another one that we're going to apply here, which is really neat, your book doesn't address it very well, which is one reason I'm glad the AP exam does. One of the few times I agree that the AP exam really covers something that's probably more useful than what we do in the book. 1, 2, 3. Well, I don't need to do all that. I'm jumping ahead of myself. Okay, so if we have just a graph and I draw a function, the question is the mean value of the function. Now, we talked about the mean value theorem for the rate of change, but this is the actual mean value of the function. So the average height of the function. For example, this x or this y mark right here in green is, would you say that that's the average height of the function? Would you say that this green mark is the average height of the function? So then you tell me when you think I get to about the average height. Sure. That might be a spot where we consider that's approximately the average height. Maybe it's a little bit lower. Who knows? The way that we calculate it is we actually take the area of the integral and then we divide it by the width of the interval. And so here's the formula. You just take the integral from a to b of f of t dt and you multiply them by 1 over b minus a. That's simply just the width of the interval. And that gives you the average value or the mean value of the function, which is, useful. Okay? All right, so we get to the main kind of problem for today. This is one of the most common types of problems you would see on the AP exam. And I'm going to be rewriting the study guide in our test this year to incorporate this kind of problem because I believe in it so much. It says, use your calculator for the following problems. The velocity of a car is modeled by the function v of t is 20 sine of pi t over 2 minus 1, where t is measured in hours and v is measured in miles per hour. Consider v of t over the interval 0, 4, and let s of 0 equal 10. If you remember this relationship yesterday that we said we went from position to velocity to acceleration? The derivative of position is velocity, and the derivative of velocity is acceleration. You all good there? So are we given the acceleration function, the velocity function, or the position function? Velocity, okay? And so the first question says, find the displacement of the car over the given time interval. So if we want to know the displacement, we just have to take the integral of the rate function, or the integral of the velocity function. So I'm going to write it like this. The integral from 0 to 4 of v of t dt. You don't have to actually write out the rule for the function. You can just say v of t. And now we're going to plug that into our calculator. Turn my calculator on, go into y equals. And you're going to want to do this. There's a lot of operations today that you're going to want to try with me to make sure that you know how to use them. Sine of, grab pi times t divided by 2, and then we subtract 1. That's my function. I'm going to go into mode. I'm in radians. I'm going to go into my window, and it looks like I need to go from 0 to 4. So I chose to use x minimum of -1, x max of 5, a scale every 1. And what's the maximum value that sine can achieve? 1, right? But if you're multiplying by 20, then the amplitude is 20. So 20 is the largest value. Subtract 1, 19 will be its highest point. So if I have it set from 30 to -30, that should be plenty, shouldn't it? Okay. So if I press graph, hopefully we'll get a nice picture of what it looks like. That models the velocity of the car. Okay. And we have this piece at the end here which says S of 0 is equal to 10. What does that mean? S of 0 equals to 10. What is position at time 0 is 10. So like when I leave my house in the morning, I'm leaving at, say, a position of 41. So the mile marker at Owatonna where I get on and off the exit ramp is 41. So this is the mile marker or the house or whatever you want to think of it. So I'm going to actually evaluate this. I go second calculate. I grab number 7. And the lower limit is 0. The upper limit is 4. And your calculator is amazing. And I get negative 4. Negative 4 what? The displacement of the car would be miles. Yep, in this situation it says we're measuring in miles. So it's negative 4 miles from where it started, okay? So see if we're connecting this together. If it's negative 4 miles from where it started, where is its position after 4 hours? Where did it start? Started at 10. So it's at 6. Yep. So it ended up further behind than where it started for whatever reason, okay? Must have been bad traffic. Maybe it turned around. Okay, maybe that's how it went. However you think of it. Okay. All right, the average velocity of the car over the given time interval. This is a new question for us. Average velocity. Well, this is the velocity function, right? I want to know the average value of that function. We go 1 over 4 because that's the width of the interval from 0 to 4 of v of t dt. Do we already know the integral from 0 to 4 v of t dt? Yeah, it's negative 4. So I have 1 over 4 times negative 4, and I get negative 1. Negative 1 what? Miles per hour. So on average, its rate has been negative 1 miles per hour. Okay, very slow. He's driving a John Deere tractor. Find the total distance traveled by the car. How is that different? Yeah, it's the absolute value. 0 to 4 of the absolute value of v of t dt. And everything I'm writing here is what's acceptable and needed on the AP exam. If you wanted to write out the whole function rule, that's fine. But writing this is fine. You might want to do, you have to write that? Yes, you do. If you don't write the bounds and dt and absolute value, they will not mark it correct. Question. Where would you put it? Around the entire piece? That wasn't probably the best notation yesterday. I don't believe that they would mark it wrong because the absolute value of the function would end up being the absolute value of the entire integral. I think. I haven't thought that through real well, but I believe that that's the case. I would use it. I've only seen that notation on the test. Okay, so we're going to do that. Let's take our calculator, and what do we have to change? Yeah, I got a second insert, and I go to second catalog. I insert an absolute value sign. Second insert, which is the delete button. And then second 0, that's your catalog where you can grab all sorts of different. Oh. Okay, so everybody, real quick, Maddie's is not allowing her to do that right now because she has a fancy-dancy calculator. And so what we'll do in that situation is if you go into mode, we're going to take her out of her fancy mode and bring it into the classic mode, I believe it says. So right now you're in the math print mode. If you go over to classic mode, there you go. Now you go back to your y equals. Yeah, so like exponents. Yeah, so you're going to have to use the caret key from now on. But that's one way to move around it. So some people like the classic mode as opposed to print mode, but there you go. Okay, so there we go. I've got it. And I do number 7. It's really fun to watch this graph. I enjoy it with some ball bouncing off the ground. There it goes. It's good times. Lower limit is 0, upper limit is 4, and this is difficult for your calculator to do. You can see mine doesn't have the amount of memory that yours does. That you guys have TI-84s mostly. Mine's a TI-83, and it's struggling. Good luck. All right. So there we go. Darren is right. We could actually do this integral by hand. We're going to learn that tomorrow, but you definitely want to use your calculator in this part of the test. So we got 50.99, and now here's where you have a choice. You either have to just grab the first 3 decimal places, so 993, or you round to the nearest thousandth. So either answer is acceptable. But on the AP exam, they'll expect you to write 3 decimal places or round to the nearest thousandth, and our measurement is going to be in miles. They'll mark that correct. So some people just write out 8 decimal points all the time. So. Yep. Very good. Yep. All right. The position of the car at 2 hours and 4 hours. Well, let's think about the 4 hours one. You guys said at 4 hours, what was its position? It started at 10. It had a displacement -4, so it was back at 6, right? So the way we figure this out is you consider the start position plus the displacement. Does that make sense to everybody, that you consider the start and you just add on it to the displacement? And that will tell you where your position is. So we're going to do that, okay? Our starting point was 10, and the displacement was the integral from 0 to 4 of v of t dt, which ended up being 10 plus -4, which gave us 6. So that's the position at 4 hours. Nope, we're going to write a new integral. Same idea. We start at 10, but instead of going to 4, we're going to 2. So we have the integral from 0 to 2 of v of t dt. And again, the AP exam is saying that we're going to use our calculator for this example. So I go back into y equals. I get rid of my absolute value, so I have my original function. And I second calculate number 7. Whoop, I paused it. There we go. Unpause. Did you guys know that? You can press enter and pause the graph. Yep. I'm a crazy guy. And then we're going to go lower limit of 0, upper limit of 2, and we get 23.465. So I'm going to go 33.465. You guys go get some brain food, and we will... That'll be part of it, yeah. If you knew it was just constant the entire time, that would be much easier. Yeah. Oh, this would be the, so I can find the integral of this, or the antiderivative of this, but I would say that any problems I've seen on the AP exam, I've maybe only seen one like this where they actually ask you to take the antiderivative for this type of a problem. They would, here's an example of some other problems we've seen. Y is equal to e to the tangent squared of 1 over x. So you're not going to take an antiderivative there. Without a doubt, they will have you use your calculator for that kind of problem. Yeah, and there's some antiderivatives you just can't find. You just can't. You got no shot. So anyway, we'll pick it up when you guys get back. What? Some brain food?
Yeah, for E. Yeah, I know. You know why? You know why, Jonah? Because he doesn't want to do his English sonnet today.
That's a good point. Yeah. Oh, wow. Okay. Yes. Okay. We finished off with 33.465 miles of the position. Look at the next question, a little bit different. It says the acceleration. How do we, Sean, be nice. How do we find acceleration? Derivative of what? Yeah, exactly. Acceleration at time t is equal to v prime of t. So if you want to find the acceleration at time 2, you do v prime of 2. There's no bell. Which one here means derivative? 6. So take the derivative at time 2, and I get negative 31.416. What is my measurement in miles per hour squared? Acceleration is squared. So position would be miles. Velocity would be miles per hour. And acceleration would be miles per hour squared. Okay. Okay. What is the average acceleration over the time interval? This is where the question gets a little bit more challenging. And this is what they want to test you on the AP exam. So did we just find the instantaneous acceleration or the average acceleration? We found instantaneous. So instantaneous is when you take the derivative at 1 point. Average is where you take the slope at 2 points. So over the time interval from 0 to 4, so what I'm going to do is, in order to find average acceleration, I'll find the velocity at time 4 and the velocity at time 0. And I'll divide that by 4 minus 0. So this is just y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Just have to understand this is creating a rate of the velocity. So we are getting acceleration, it's just the average. So this is just slope, 2 points instead of 1. So the key word here is average, okay? Now, notice where else did the word average come up in this problem? Yeah, part B. Well, look at it. It says average velocity. Well, you're given the velocity function. In order to do that, we have to use the mean value of a function. Average acceleration, that's a rate. We use slope. So here's how I calculate that. I need a value for v of 4. So I go second calculate. Which one will give me value? Number 1. Whoop. So second calculate number 1, and I plug in 4, and I get negative 1 minus second calculate value number 1, and I plug in 0, and I get negative 1. You could go to the table as well. It's a free country, Sean. We get 0 divided by 4, which is 0 miles per hour squared. We all good? Okay, let's look at the second type of problem. We are going to look at a table. It says let R of t be a rate function that measures the rate at which snow falls in inches per hour. It asks us to consider the concavity of R of t and use it to determine an upper and lower bound for the total snow accumulation over the course of 6 hours. So now we're not given a function. We have to look at kind of some data. So what I'm going to do is I'm going to plot out 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. As I plot this information, I have 0, 0. I have 1 and 0.1. I have 2 and 0.3. 3 and 0.6. 4 and 1.2. 5 and 2.4, and 6 and 4.8. So that's a general representation for the type of function that we're looking at. So if we're asked to look for an upper and lower bound, what it's really looking for is what kind of sum would give an overestimate and what kind of sum would give an underestimate. So as you think of right-hand sum, left-hand sum, which one would give you an overestimate in this problem? Let's try drawing one. If I draw a right-hand rectangle, is that an overestimate or an under? So right hand will give you an overestimate. So it's increasing and concave up. It's an increasing and concave up function, and in that situation it creates for us an overestimation. Please note that if it is concave up but decreasing, then that would be different, right? And if it was concave down but increasing, that would be different. If it was concave down and decreasing, that would be different. So you have to think of all four scenarios, really, okay? And we'll kind of solidify that as we move along towards the AP exam. So right hand will be overestimate. Left hand will be an underestimate. Okay, so let's do a right-hand estimate. Right hand from 0 to 6. Which numbers will I add up? Yeah, 0.1 plus 0.3 plus 0.6 plus 1.2 plus 2.4 plus 4.8. That should give us an overestimate for how much snow would actually have accumulated. So I got 1 and 1.2 makes 2.2, 7, 9.4. What is the width of each one? 1. Thank you, Kelsey. So we get 9.4 what? Yeah, you got some snow falling. We won't measure in centimeters. Left hand. So how will that change? 0 plus 0.1 plus 0.3 plus 0.6 plus 1.2 plus 2.4. Good. We get 4.6. So we're looking at exactly, we could calculate a trapezoidal sum here right now, which would be probably a nice approximation. But let's bring that problem up as we look at B. It says S of 0 is equal to 2.4. What does that mean? Yeah, there's 2.4 inches of snow already existing on the ground. So it says, let's use T sub 4 to approximate the amount of snow coverage at time equals 4. What does T sub 4 mean? The trapezoidal sum of 4. Exactly. So that's what we're going to do. We're going to take 2.4 and add it to T sub 4. And that will be our snow coverage at time 4. Well, I need to take the right hand of 4 plus the left hand of 4 and divide it by 2. So right hand of 4, this is my interval from 0 to 4. So I add up at 1, 2, 3, and 4. So 1 plus 1.3 plus 0.6, I'll be 1, so 2.2. And then, if I do the left hand, I'm going to do 0 plus 0.1, 0.3, 0.6, and I get 1. So 3.2 divided by 2 is 1.6. So I have 2.4 plus 1.6 is 4 inches of snow. It's sitting on the ground. Approximately, that's a best estimate at time 4 hours. Now let's think about it. As we look outside, we watch the snow fall. We may see it fall at a steady rate, but sometimes that rate may increase or sometimes it may decrease. For example, all of a sudden you might look out and say, well, it's snowing harder now, so the rate's increasing. As you look at this, is the rate increasing or decreasing? It's increasing. So we'd expect it to be positive. It says use a table to approximate r prime of 3. So the rate at which the rate is increasing, the rate at which the snowfall rate is increasing at time equals 3. Well, it used to be that we went to our calculator, we did the derivative at time 3. We don't have that option here, do we? So we're going to estimate. What's another word for derivative? Slope. So we want to approximate the slope at 3. So I'm going to choose 1 point to the side of 3 and 1 point to the other side of 3 to find the slope. So in other words, we'll find r of 4 minus r of 2 divided by 4 minus 2. That's my y sub 2 value minus my y sub 1 value over x sub 2 minus x sub 1. That will give us the approximate change at that time. So what is r of 4? (1.2) minus, what's r of 2? 0.3. Okay, I'm just asking because I can't see it. And 4 minus 2 is 2, so I get 0.9 over 2, which is 0.45 what? Close. We're taking the rate of a rate, right? Rate of a rate. Okay. If you think about the label, it's 0.9 inches per hour, and then inches per hour, and then we're dividing that by 2 hours. And if you would just multiply by the reciprocal, that's what causes your label to be squared. Okay. Now it says r prime of 4.5. Well, do you see 4.5 up there? No, that would be right here though, right? It'd be right at this spot. So yeah, we'll use 4 and 5. Very good. So r prime of 4.5 is approximately equal to whatever r of 5 is minus r of 4 over 5 minus 4. What's r of 5? 2.4 minus 1.2. No, you don't. So if you wrote the 2.4 minus 1.2, that would be fine. Everything I'm writing is stuff that I see very common on the answer key. So I would say that what I'm writing is what they would really like to see communicated. Yes? It's all on paper. The math test is 3.5 hours. No, half of it is multiple choice, half of it is free response. Yeah, you can't fake your way through the free response. All right, last question. What does 1/4 integral from 1 to 5 of r of t dt mean? Where have you seen something like that before? Average value. So 1/4 integral 1 to 5 r of t dt is the average value of what? What function? Of the rate function, right? So you might want to write the average value of the rate of snow falling. Okay. Now I wrote that when I first had the type of problem and I got it incorrect because it says use units in your explanation. So I said, okay, average rate of snow falling in inches per hour. And I still got it wrong. And I said, why? And they said they want you to talk about 1 and 5. So from time equals 1 hour to time equals 5 hours. And you'll see this played out again and again as we prepare for the AP exam later on, but they want you to talk about the bounds, they want you to talk about the units, and they want you to say the average value of this function. Caleb, you had a question. Yes, you could, a lot of times you could go back to the directions and pull some of that information right from there, okay? So we end with this then. Use the right-hand sum to approximate 1 over 4 integral of 1 to 5 r of t dt. So that's going to equal 1/4 times, now we got to look at our interval from 1 to 5. So I'm going to look from 1 to 5. Okay, and am I doing a right hand or a left hand? Right hand. So I start with 2, then 3, then 4, then 5. So 0.3, 0.6. Plus 1.2 plus 2.4. So I get 1/4 times 0.9 plus 3.6 is 4.5. Right? Or 9/2, which is 9 over 8. 1.125. And this is the average value of the rate function. So inches per hour. I don't pretend that this stuff's easy. You know, as you see it, some of these free response questions will give you a run for your money. I'm going to give you the worksheet. I'll go over a couple problems if you guys want to see it. There is one small change on the worksheet, and it's right here on the worksheet where you see 240. It should be 480. I'll point that to you as I hand it out. We do have one more page to get through, but we won't be able to do that till tomorrow.